So now we do some math on this. And so let's see. We have a cellular system. It has a cluster size of 7. So if you divide the area into hex things, remember the cluster size 7. Repeat 7, 7, 7, 7 everywhere. That's the cluster size. User density is 100 users per square kilometer. Allocated frequency spectrum is 900 to 949, 49 megahertz. Bit rate required per user is 10 kilobits per second uplink and 10 kilobits per second downlink, and modulation produces 1 bits per hertz. So these are numbers that, are example numbers. They are not real numbers. These are example numbers. Now you are in the beginning of designing the GSM kind of stuff, so you should know as to how they designed it. So now using FDMA, how much bandwidth is available per cell using FDD? So if you are not doing GSM, you are doing the old one, the 1G, then you are giving the whole frequency channel to each user, right? How many bandwidth is available per cell? How many users per cell can be supported using FDMA? What is the cell area? What is the cell radius? So all of this, basically we will solve one by one. The other question is, if the available spectrum is divided into 35 channels and TDMA is applied within each channel. So instead of whatever we talked about 24, let's say 35 channels, what is the bandwidth and data rate per channel? So this is all state division in some sense, but we just want to go through that. How much bandwidth is available per cell? So you have 49 megahertz and there are 7 cells. So you have to divide that into 7. 7 megahertz per cell. If you are going to use FDD, then you will use 3.5 for uplink and 3.5 for downlink. Now, you have to differentiate between FDD and FDMA. Slide, all right? What is FDD? It's duplexing method. Duplexing method means that how do you do up and down? Okay? It could be TDD or FDD. FDD means you go down on one frequency and go up on the other frequency. TDD means that you go down on the same frequency and go up on the same frequency using time. TDD. What is FDMA? What is TDMA? FDMA is that basically 25 users are going to use, how they're going to share by frequency. TDMA by time. Right? So don't confuse between FDD and FDD. So using FDMA plus FDD. So it says using FDMA slash FDD. So because of FDD, it becomes half. If it was not FDD, it would remain same, right? So you get 3.5 megahertz. How many users per cell can be supported using FDMA? So now, if you have 10 kilobits per user and you're getting 1 bits per hertz, you need 10 kilohertz. And with 3.5 megahertz, you can support up to 350 users. Okay, first of all, do you understand how did we got 10 kilohertz?
Yes, it's 150 a second.
Right, and you understand how we got 3.5 megahertz? So if you divide this into that, you get 350. 3.5 megahertz divided by 10 kilohertz is 350. I should have put that here, 3.5 divided by 10, but anyway, 350. What is the cell area? Since there are 100 users per square kilometer, so now to support 350, we need 3.5 square kilometers per cell, and therefore the cell radius can be calculated to be 1 kilometer. 3.5 square kilometer per cell. Okay, because we told you that there are 100 users per square kilometer. Right? And now one tower can support 350 users. Right? One tower can support 350 users, and 100 users live in 1 square kilometer. So that is 3.5 square kilometer. If there is no, basically this is a question which is in the homework slide, and it's all very simple division, except you have to know what to divide by what and when. So there are 3.5 square kilometer. That means that each cell has a radius of 1 kilometer, pi r square pi. Right? So there is a square root there, but other than that, it's very simple. Part B. If the available spectrum is divided into 35 channels and TDMA is employed within each channel, what is the bandwidth and data rate per channel? Okay, so now you have to differentiate between the user and the channel, just like we did there. There was a multi-frame, a frame, and a burst. Right? So first, right now we are talking about these channels, 35 frequency channels. So since there are 3.5 megahertz and we're dividing into 35, each of them is 100 kilohertz per channel, which is giving 100 kilobits per. How many slots are needed in a TDMA frame to require number of users? So now each user needs 10 kilobits and you are getting 100 kilobits. So in each channel you can put only 10. Yeah, if for example it comes 3.5, I mean, then you just use 3 users. I mean, the thing is, this is just teaching you the method, and then you use your common sense when you're designing in the real world. Of course, you would not say, well, I will support 3.5 users. And like here, they had 157.25 bits. What do you do with that? They just leave that 0.25 bits alone. Right? So same thing. Yeah, if you get fractional answers, then just don't be aggressive. Yeah.
For the TDMA, do we need to use the half of the channel or
FDD?
No, I mean, yeah.
Okay, so this one assumes FDD somehow. So it doesn't say FDD here, but it assumes that whatever calculation did here. So first what we did was we divided the spectrum into FDMA, and then in each FD we are going to do TDMA. Right? That's how GSM is. That whatever spectrum you are given, in 1G you divided that into FDMA, in 2G each frequency is divided into TDMA. Right? So this 49 by 7 and 7 by 2 was already done in this part. 3.5 per channel. Now that 3.5 became 100 kilobits divided by 35, and 100 kilobits became 10 users. Yeah, because we have 1 hertz per bit. Right? That was specified somewhere. 1 hertz per bit.
That's the first part. 1 bit per second.
Yeah, per hertz. No. The thing is here. Yeah, 1 bit per hertz.
So the second equation, you will be doing a division or multiplication with 100 kilohertz.
Oh, just think about it. So let's say you get 2 bits per hertz. I mean, the right way to say is 2 bits per second per hertz, BPS per hertz. Right? If you're getting 2 bits per hertz, 100 kilohertz will become how much? 200, yes. You got it. All right, and today you can do 256 QAM, which gives you 256 is 2 raised to 8 is right, 8 bits per hertz. So but this is very old days, right? So it's 1 bit per hertz. So now those 10 kilobits per hertz means that you can have 10 users on each channel using TDMA. If the TDMA frame is 10 millisecond, how long is each slot? So you take that 10 millisecond slot, and there are 10 users, so each user gets 1 millisecond. Right? So now your burst size. How many bits are transmitted in each time slot? So 1 millisecond by 100 would be 100 milliseconds. So basically, what we have done is, these are the real numbers that they finally ended up, but I've just told you how they calculated all this, because at that time everything was variable and possible, and so now you can these numbers are now fixed, right? But if you are designing your own GSM version 3, then this is how you do. And then there's just the homework, basically line for line.